questions as you want at the end. Alright, so I just want to quickly start by saying I actually took a bit more of a casual approach to my presentation today. I figured down the road in master's degree or whatever, I'd have to be more professional, so I kind of wanted to have some fun with this one. And so this project was completed as part of my NSERC-USRA that I did last summer. So I got a little sum of money and I got to work under the supervision of a grad student at this wonderful research station, Salmon Coast, up in the Brown Archipelago. So my project title is The Effects of Bismarck Brown Y Dye on the Growth of Juvenile Fraser River Sockeye. Sounds super cool, right? To be honest with you, I had a lot of trouble coming up with a research question, so I sat down with my supervisor and we decided on a project that would inform his PhD project. So I wanted it to be useful in some way. So first, we have Fraser River Sockeye. They're very iconic, very well known to BC. They have a lot of cultural, economic, research purposes, but they've been a little in trouble recently because of salmon aquaculture. It took off and became very popular in the mid-80s. It went from about 10 fish farms to about 180 in the area. And so they brought a lot of negative ecological effects along with them. The one that I'm focusing on is the issue of sea lice. I don't know if many of you know very much about it, but I won't go into too many details. But there's been a lot of research of the effects of sea lice on pinks and chums of the area. But sockeye, they're larger when they're in the ocean and they're also harder to catch, so there hasn't been much research to do with sockeye. And so just to give you an idea, you can see the Fraser River on the bottom right there. That's where the sockeye emerge from. Some of them go around the outside of the island, but the majority funnel up through all these little islands, and that's where all the fish farms are concentrated. So the fish are forced to swim past them. And so as I said, my project is informing a larger study. So one of the end results of that study is to be able to have lightly infected fish, heavily infected fish, put them together in a net pen for however long, and then we wanted to be able to tell which category they were in when we take them out. So we needed a method of marking them. Now sea lice, they can jump from fish to fish, and so we needed a method of marking that didn't involve handling the fish. So hence why we chose a dye. So there are two questions I was looking at. The first one was, what is the length of time that we needed to hold the sockeye in order to see a significant growth? And I also wanted to know, does this stain affect the growth rates? Because that would be very important to know if the grad student was going to use it in his project. So step one, we had to catch the fish. So this is a beautiful morning out in Johnstone Strait. We used a modifying purse seine net, which you can see in action there. It's a really neat but very challenging process to get those fish. In the end, you have a little purse of the fish just hanging off the side of the boat. There's pinks and chums mixed in there as well, so we have to select out the sockeye and put them in a tote of water. Step two, use the crane, because we can. So we had the fish in a tote in our fishing boat, but then we needed to get it onto our motherboard. And this big ship and the crane was new to us this summer, so we were very excited to try it out. And then we had to, step three, keep the fish alive. They're very sensitive to environmental change, so we had to have ice packs and bubblers. And step four, transport. So these go hand in hand. We had to keep them alive for about a 3-hour transport up to get to our experimental site. And so that black box is where we caught the fish, and then we had to transport them to the island just above it, and as I said, it was about a 3-hour transport, so pretty slow going. And the end destination is here. This is called the Shanty. It was our site where we held the fish and performed the experiments. And so step 5, measure the fish. This is the data I actually got to play with. So we had dyed and not dyed. Peter reminded me that I didn't actually have a picture of a dyed fish on here, but the way it worked is that the dye is a powder, and you mixed it in water, and we had a huge tote of stained water, and you immerse the fish in there for about an hour and a half. And so I had 4 net pens, and then we measured 10 dyed and 10 not dyed into each net pen, and we measured them into the experiment 5 days later and 10 days later. And so from that, I got to learn how to use a computer program called R to analyze the data. So here we have our 4 net pens. On the x-axis, there's the not dyed and dyed. And then on the y-axis, there's the length, which is the fork length of the fish, from the snout to the fork in the tail. And there was also the 3 days that we measured them, measuring them in day 5 and day 10. And so what this graph is generally telling us is that the fork length is increasing over the 10 days of the experiment. However, it wasn't a significant amount. Now, grouping the dyed and not dyed fish together and calculating the growth rates for each category, we determined that the difference in the growth rates between the 2 categories was also not significantly different. Now, these bars are actually standard error bars, not confidence intervals, but I performed a t-test to determine the significance. And so in summary, the Bismarck Brown Y Dye can be used in the subsequent studies, so grad students could use it for his project. But we found that we would need to hold the fish for longer than 10 days if we actually wanted to see a significant growth. And that is it. Thank you.